Hello and good morning. It is Friday, July 12th. My name is Rob. I am that developer dad, and we're building a console application using C# and a whole bunch of classes. I'm halfway tempted to change the name of this series of streams to "Oops, all class libraries," but no, I think we'll just keep it where it is. Yesterday we got the model for generic rule sets and a game system specific rule set. We didn't necessarily finish building out a whole rule set. That's a lot of work. It's a lot of typing, but I think we have a pattern by which we can, out in the setup portion of our application, tell the application which rule set we want to use, and then that will attach itself to the rule set access component that our townsfolk generator is going to consume when generating random townspeople for my D&D game. So without too much further ado, let's dive into the code. I did make a couple small modifications to the way I'm instantiating the 5e rule set and bringing it into the rest of the application yesterday. So before we dive in, or before we start adding new code, I do want to quickly review what I did there. And it's an implementation of a fairly common pattern that anybody who's worked in ASP.NET Core would be familiar with. Let's go down to our console client. Excuse me. And let's take a look at program.cs. Now, anybody that remembers yesterday would recall that I had this load from assembly or load assembly or get assembly or whatever method down here. And I was actually able to get rid of that by implementing a pattern in our rule set access. All I did was I added a new method to iRuleset access called initializeRuleset, and it accepts an assembly. And then down in the specific assembly, where is it? I have a rule set initializer, and I created a extension method. I did public static class, rule set initializer, public static. It returns a rule set and iRuleset access. It accepts an iRuleset access. And all we do is we obtain the type of some class in our local assembly inside the D&D 5e SRD project. We derive the assembly from it, and then we pass that derived assembly into the rule set access class itself, and then we return it out. And what that lets us do is down here inside our setup, we can simply declare a new, whichever implementation of rule set access we want to use, and we say use 5e SRD. We call that extension method, and it registers that set of rules with the rule set access provider class. And then we can inject it and use it wherever we need it. So let's start doing that. Let's, instead of using a hard-coded string to define our townsperson's species, well, first we need the list of species we can choose from. So var species choices equals NPC rules dot species rules dot list. And that's just a property. Now we need to pick one of these, and we want to pick one at random. So luckily we've got that dice generator, that DiceEngine. But let's take a look at how many different species we have. We'll just go in here, go to the implementation. 1, 2, 3, 4, 5, 6, 7, 8. We do have a D8, but I don't want to rely on just rolling a random D8, subtracting 1, because arrays are, of course, 0 indexed, and then picking that number. I want to simulate shuffling cards so that we can pretend that we've got a list, a stack of 8 cards, shuffle them and pick the top one, and that's going to be our species. So a good place to put that, I think, would be in our engines. Now, I don't want to add this to the DiceBag class, but what if we created a new contract, and we'll call it card stack. And that's just a metaphor. So let's do this. We'll do card stack. I'm not going to fuss about the namespace and the braces and stuff like that anymore. I think that was just me being old-fashioned and dogmatic. Simulates the behavior of a stack of cards. And the only thing that we need to do here, we're not going to add a card to the top of the stack or anything like that. Nope. Let's not let Codium, my free version of Copilot, or my free equivalent to GitHub Copilot, get in our way. What we want is string pick 1. We're going to pass in a string array of choices. And I don't want to use choices. Let's change this to card. Now that's pretty limiting. We can't guarantee that we're always going to be dealing with arrays of strings. So what if we did this? Make it generic, an array of t, and we're just going to return 1 of those t's. Now what we're doing here, this is called a generic method. And t is shorthand for some type, some class. So now instead of passing in an array of strings, we're going to pass in an array of some class that when the compiler runs, it'll resolve all of these type references for me. But this type of grammar means I don't have to write a separate pick 1 method for every possible type that might manifest itself as a card or a choice. So let's comment this guy out. So picks 1 card from the stack. Well, and that actually needs to be card stack. Or perhaps a more succinct name for this variable is deck. And the type param t is the type of the card. We no longer have a parameter called card. We now have deck, an array of t representing a finite set of options to choose from, returns one of the cards in the deck, and that's about all we need on this interface for now. Eventually, we might want to keep a stack of these cards and deal them out across another collection of recipient objects or whatever. But for our purposes right now, all we need is this pick one. So let's implement it. And we're going to add, not to contracts, but to the actual root of this class library, class card stack. No. Deck. Yeah. Card deck. No. Naming is hard. Deck simulator. Yeah, I like that. Now, there's an important note that we need to add here. Shuffles the deck, then chooses one card to return. There, that's a little bit more descriptive. I want to rename this. Rename. Oh no, I don't want to delete it. I want to rename it. Here we go. Not enough coffee yet this morning. Card deck. There we go. And I'm going to change this to card deck. Good. Save it. Now let's come out to our deck simulator. We're going to implement iCard deck. Great. iCard deck, T, pick one. And it finally caught up to us. Let's use the shortcut on a Mac. That is the command and the dot key to bring up these quick fix suggestions. On Windows, that is the Windows and the dot key. On Linux, you probably have to type 6 pages of console commands. So pick one. All right. Before we go further here, because this is a pretty finite, simple operation that doesn't involve a whole bunch of dependencies and stuff, let's add a test. So we're going to add a new file, and it's just going to be a class file. Yep. And deck simulator tests. There we go. And we are going to use XUnit. Let us create a fact. Public void deck simulator test. From array of from integer array returns 1. So our var test object, we're not going to use a var, we're going to use iCardDeck. There we go. Var deck equals new int array. I don't want to do it this way. Let's go enumerable dot range. Oh, what are you doing? Dot range 1 to 6. No, we're going to go 1 to 20 dot to array. So here's our arrange. Let's do this right. Arrange act assert. And why am I doing this for one measly little method? Well, because I want to be able to test or run experiment with the code without having to add calls to my console app and spin the whole darn thing up and step through code and then have it go through all of its stuff before it gets to this pick a card thing. I just want to make sure that the card picking concept works. So test object pick one deck, and pick one must return an int. Very good. And finally, assert dot true deck dot contains the result. All right. Save that. It's going to let us run it. Probably not until we build it. Let's build it. We'll load up our test lab. And it's building, doing all the things. Seems to be done. Excuse me. It's building again. DiceEngine tests, dice tray tests, deck simulator tests. That's what we want. So let's go ahead and run it. And it's going to vomit all over us. Oh yeah, it failed with a not implemented exception. And that's not a surprise because I haven't done a darn thing to make this do anything. All right. So we need to pick one. And that means we need to shuffle the deck. Shuffle the deck. Pick the top card. Return the top card. So picking the top card is easy. Var top card. We're just going to pick the first element in the array. And we're going to return it. Now the trouble with this is it's going to give us the first element in that array every darn time we call it. And I don't love that because it's going to give us the first thing every time, and we're just going to end up with a village full of the same types of people, and that's going to be boring. So we need a way to randomize this array. And I happen to know of a method called shuffle, and I believe it only works on flat arrays. Please tell me about the shuffle method that was introduced in dotNet Core recently. Now, I think I've played with this method once or twice before, but I've never actually used it. So random shared shuffle numbers. Okay, so it became available in .NET 8 and will be available in .NET 9 when that drops. I believe it goes GA in October, but I don't tend to use odd numbered versions of the framework. Performs an in-place shuffle of a span. So I need to cast my incoming deck of cards as a span. Okay, in an array or span. Shuffle T, values, okay. Time complexity is 0n. I've seen this notation all over the place, and I know it deals with the efficiency of an algorithm or what have you, but I've never, in my years and years of doing this, have dug into that. I would get my butt kicked at LeetCode. I guarantee it. So int numbers, we give it an array of numbers, random.shared.shuffle numbers. Okay, and it just does it in place. All right, I don't necessarily want to do that constantly. Or rather, I don't necessarily want to alter my array. So we are going to create a working copy. Var working copy equals deck.toArray. Now we're going to say, let's bring up the syntax. And I don't 100% trust this, but let's see what we get. Let's copy that, random.shared.shuffle, and then we're going to dissect it over here. Working copy. And instead of picking the top card from the deck, we're going to pick it from our working copy and return it. We'll just run it first. And then we're going to step through to see what this random.shared.shuffle method does. We see that it passed, but I want to step through. Oh, assert.contains. I don't have to use true. That's what I get for not having an encyclopedic understanding of substring to be expected in the string. No. Result deck. That's what happens when I don't have an encyclopedic understanding of everything I use. Let's rerun the test real quick to make sure contains does what I need it to. It still passes. Let's drop a breakpoint right here and debug our test. It's doing the thing. Our test object has 20 items in it. Good. Let's step in. So the very first thing we're going to do is create a working copy of our array and deck. Good. Now, I'm going to be curious in just a second. I'm going to be very curious in just a second. But did it actually create a copy or just give me a reference? So here's our working copy. We can see that it's been shuffled. Here's our deck, and it's still in order. Good. Good, good, good. So we know that worked on our working copy. There's that. Let's step over. What's our top card? It's a 10. And we're good. So that means we can probably pass a list of arbitrary things into here. Now, because this is using randomization and all of that stuff, I want to make sure it does it fairly randomly every time and that I don't get the same result every time I call pick one. So how are we going to do that? How do we ensure that a given deck is... There's no such thing as truly random with code, but we can kind of get a feel for it not randomizing in the exact same way every time. That the shuffle is different almost every time. Let's run this a bunch of times, collect the results, and keep a count of how many times we get the same result. So for this, we're going to need, I think we ought to do this as a second test, actually. So it's going to look very similar to this test. So we're just going to copy, paste, and rename. Deck simulator test from integer array. Shuffle is random. And we can get rid of these notes. So what do we got to do? We got to create a way to record each result as it comes out and increment a counter for each result across a loop of runs of this method. So result index accumulator is a new dictionary of int and int. What are you complaining about? Okay, we probably have to reference system.generics. Yep, or system.collection.generics. Now, for int, got to put it in parentheses, int count, have some coffee. Excuse me. Int iteration is 0. Let's do it 1,000 times. We're going to cut this up into here. So var result equals test object.pick1. We're going to pass in the DAC result, and if the result accumulator contains a key, already has an entry for whatever was picked, we are going to result accumulator result plus plus. We're just going to increment the value of that result in the dictionary by 1. Otherwise, result accumulator result equals 1. There we go. So we will have collected the results of 1,000 pick one operations on this deck. And what's a good test to make sure we're not getting the same result every time we run this with the same deck of cards? Well, I want to see how many entries are in that dictionary. So, int distinct results equals, we're just going to count the entries in the dictionary. We're going to say assert true distinct results is greater than 1. Let's build our tests to get it included in our test runner. Excuse me. And let's just run it. We'll run them all. All of our deck simulator tests. Go, go, go. It may not include the latest test. Oh, it did. Very good. And just because I'm curious, I want to debug this one where we run 1,000. But I don't want to step through every iteration of 1,000. So I'm just going to come down here until after that gobbledygook is done. And I want to just visually inspect the results. So let's debug this one. All right, we're here. Our result accumulator should have no more than 20, but and it says only 1. So something in my loop ain't quite right. But it seems to have hit every possible card. And I have a feeling that I did the assignment incorrectly. accumulator result equals, let's just do that. And we'll debug it one more time. See if we have a shortcut up here. Yeah, here we go. We'll debug it one more time just to make sure I'm recording my aggregates correctly. All right. And we can see over here in our variables locals, it still only has the 1 because I'm a dummy. Ah. Can you spot the error? As a matter of fact, I'm going to screenshot this. Whoops. I'm going to screenshot this. And I'm going to save that because that's a funny haha. So I'm wondering why the heck is my result accumulator always coming up with 1? Well, it's because I'm doing my test to see if the key already exists. And if it does, I'm incrementing by 1. And then I'm immediately explicitly setting the value of that element in that key in the dictionary to 1 because I forgot else. And I know how I forgot else because I let my AI assistant just blast this code in and I didn't carefully go inspect what it did for me. The moral of this story is when you get your code from anywhere other than your own noggin, always, always, always step over the code, even if you're just stepping over it with your own eyes, and make sure it's doing what you really intend for it to do. That goes for GitHub Copilot, it goes for Codium, which I'm using, it goes for anything you might find on Google or Stack Overflow or whatever. Always inspect and understand every line of code that you introduce into your own code base. Always. Even when you don't fully understand the concepts that are at play. Because taking that time to gain that understanding, you won't have to look it up next time. Or no, that's not realistic. You'll still have to look it up next time. I've been doing this for long enough to know that there's stuff that I got to look up every time. But by at least stepping through and making sure it's gonna behave itself, you're gonna save yourself a lot of pain. And yes, complacency is a problem. I fall into it all the time. You will too. Trust me. It's just something you need to be aware of and keep an eye out for because it'll happen. All right. Let's take another look at our result dictionary here. And it's still playing the fool because I have a feeling that I'm doing something dumb here. So instead of bashing my head against this and changing that and so on and so forth, let's cut these iterations down from 1,000 to say 5. And I want to step through and see what the heck I'm doing here because I'm obviously doing something wrong. And I can't blame Codium anymore because I said, yeah, go ahead and use this code, include it in my code base, and it became my code. It's a very important thing to keep in mind when you're doing stuff with external assistants. So right now we have no results in our dictionary. Good. Let us run. Why did it do that? It's silly. Result accumulator.count is 5. Okay, well, it picked those, and that's fine. So for some reason, can I right click and set my next statement? Can I bring this up here? No. Oh, come on. Ah. So there's that. I actually want to step through this process here. So we're going to debug it one more time. But we actually got to see that of the 5 iterations through, it picked a different one every time. So we're here, our result, that's a 10. So if result accumulator contains key, it's going to be false this time. Okay. Next, our result is 17. Let's drop a breakpoint here. And we'll just run. Let it go. All right, so our result here is 10. Good. The result accumulator for result is 10. No, wait. I think I see part of the problem here. But let's see. All right, so we only have 4 distincts. All right, let's do this a little bit more explicitly. We know we're dealing with integers, so we can stick with ints. Deck, okay. Var int current result count equals that. Int new result count equals current result count plus 1. And rather than try to do something cute and shortcutty, yes, it's more lines of code. Yes, it's more keystrokes. But yes, that's so easy to understand. Even somebody that's never read C# before can figure out what's going on there. One more time. And I'm going to bump the iteration count to 100. Debug. Because I didn't want to spend the entire hour this morning writing unit tests and then debugging my unit tests. So our current result count is 1. Our new result count is 2. Let's step over this. Oop, our result is 10. Let's take a look here. And 10 now has a value of 2. Perfect. I'm going to eliminate that breakpoint, let her rip, and now we're going to re-inspect our result accumulator. It's got 20 entries in it. And Each one of those entries has been picked at least once. Beautiful. And our distinct results is 20, or it will be. Yep. So we ran it 100 times. It picked every choice in the deck at least once. And our test passes. And I trust the component now. And I learned that sometimes, or I didn't learn that, but I was made to remember that sometimes writing a little bit more code and making it explicit is a whole lot more foolproof than trying to do something shorthand and cute. And I'll be able to come back to this in 6 months and look at what I'm doing and understand immediately what's happening. Excuse me. Simplicity always wins. That's the soundbite. So our deck simulator, we're cool. Our card deck, all right. So we need a card deck. So how do we choose a species? We can get rid of this. Boop. So we need a card deck. So I card deck equals new. Whoops. And let's call it Shuffler. The Shuffler deck simulator. And we just broke the dependency inversion principle. We've just instantiated a new instance of an external component directly in our code. And that means if I want to use something other than the deck simulator for this later, I've got to come in and change this line and any other place in this component that uses this line to use something else. So let's fix this. We need read only deck, not a deck roller. What did I call it? iCard deck. Shuffler. And we need to inject it. Whoops, here we go. iCard deck, Shuffler. And then we just assign it. Shuffler equals Shuffler. Very good. And now, var selected species equals Shuffler dot pick one. And I have to spell it right, of course. The type arguments for method iCardDeck.pick1 cannot be inferred from the usage. Try specifying the type arguments explicitly. Well, aren't you a stinker? So species choices. Why is that a func? Let's go to the implementation of this. What's it returning? This should be an array. Yeah. We're returning this. Okay, very good. System func of string array. Is it that? Okay, now it's a string array. I thought, oh yeah, of course, it is a method. Ah, okay. I just got lost in my own API choices. So species choice, selected species. Selected species. Save. And now we've broken our console app, but we're going to fix this real quick. And I card deck and I'm going to call it card service is a new deck simulator. And we have to provide that card service to our TownsfolkManager. And now all of that's happy. I think we've got some warnings down here. Theory method on dice bag test does not use. Okay, yeah, I don't care about that. We're going to save our TownsfolkManager. I'm going to come down to Program CS, and we don't need to test the species list anymore. That can go away. We still have to feed it to the generator console. But let's run our console client and see what we get. And yeah, it's got to build and do all the things. And it's running slowly. Here we go. And we have generated ourselves an NPC that is a dragonborn. Hooray. Now I want to run it again, but I don't want to go through all that gobbledygook. So let's collapse tests. We will reveal in Finder. Here's the Finder. And what we're going to do is we're just going to traverse these folders to where this thing lives. And look at all these files. There's not too many of them though. So how do we run this from the terminal? We're going to open a new terminal right here at this folder. And we're just going to say dotNet run console client.dll. Engage. Couldn't find a project to run. Oh, you stink. Does that work? Nope. I can never remember how to. What are you doing, Rob? Okay, there's that. Great. Let's go back to Copilot. I'm using .NET Core on a Mac. How do I run a console app from the command line in the bin debug framework folder? I can never remember. Okay, navigate to your project, build your project. I built it. Run your app. And do I need to be in .NET run your app.dll? Well, that's not working because it's being silly. So that's fine. Let's just pop out and say .NET run. Is it going to make me wait for the build? I hope not. It's clearly making me wait for the build. But we got a human this time. Whoops. And let's do it one more time. We got another Dragonborn. One more time. There's got to be a way to run these things without. And we got a human. Great. I wonder if my Mac is going to let me double click on an exe. Oh, it sure is. We got ourselves a half elf. So, it's a Unix executable file. Quick actions. No, I don't want to open it in VS Code. New terminal folder. Can I just do console client.exe? Command not found. I'll bite it. For some reason, I've never gotten it straight how to run these Unix commands from the command line on a Mac. There are times I miss Windows. But we've just integrated all kinds of stuff. Let's take a look at our architecture diagram real quick. So what have we done so far? We have our console client. Great. It's able to call into the TownsfolkManager and give it a dice bag and access to our rule set. And then our TownsfolkManager is able to use those tools to start picking random things from lists. And then it prints them out in our console as a JSON file. This afternoon, I want to switch my focus from adding stuff to the TownsfolkManager to using perhaps a little bit better way of doing this dependency injection. And we're going to talk about using the dependency injection library that Microsoft provides as part of the .NET framework to do all of this stuff. We might also clean up the generator console class so that we're not passing species data in specifically anymore. And we should probably, we've got a minute left. Let's go ahead and formalize our dependency on the dice bag. Private read-only I dice bag. Dice bag. And let's add it here. Dice bag equals dice bag. Save it. Program.cs is currently broken because we're not satisfying the needs of the TownsfolkManager constructor. I'm going to leave this until this afternoon. So I will see you all at 1 o'clock p.m. Eastern Time right here on Twitch. I'll be archiving this session over to YouTube, and you can find me on all the social medias at www.thatdeveloperdad.com. And there's even a link there that if you find this stuff valuable, it'll help you buy me a coffee. So if you're feeling generous, I love coffee, and there's a way to get coffee to me right there on the website. See you this afternoon, folks.